Hi everyone, my name is Mrs. Fitzpatrick. I am a high school math teacher, and today I'm going to be going over the law of cosines. So previously in a lesson, we talked about the law of sines, and there were a bunch of cases that we went over where it was appropriate to use the law of sines. And to solve triangles, we are going to want to use the law of cosines if we are given three pieces of information about our triangle. And specifically, the first case would be two sides and an angle, where that given angle is right between those side lengths. And that would look something like this, where we have side, so we're given maybe this side, and then an angle, which maybe is right here, and then we're given the side length that is also adjacent to that same angle. So side angle side is an appropriate case in which the law of cosines might be a good strategy to use to solve for missing sides or angles. The other case in which it might be a good idea to use is if you're given all three sides but none of the angles. So that case would be side, 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 where you are given all three side lengths of your triangle. Now, you don't have to worry, kind of like we had in the law of sines case about the ambiguous case. You would use law of sines if you are given an SSA, side-side angle, where the angle's not between the two side lengths. But these are the two cases in which you'll have to use law of cosines, and you don't have to worry about multiple triangles or no triangles fitting the given information when you're given these three pieces, unless it really doesn't form one, but that you can check by making sure that the sum of the two sides of the triangle exceed the third. But we're not going to see any of those cases today. So we're going to start with just the formula for law of cosines. We can actually write it in three different ways. So before I give you the actual formula, we're going to go ahead and label our triangle. So I have A, B, and C. Remember, we use capital letters to denote the angles, and then their opposite sides match in letter, but we use lowercase. So the side opposite of angle A will be lowercase a, the side opposite of angle B will be lowercase b, and the side opposite of angle C will be lowercase c. Okay, so we can actually modify this formula depending on what you want to solve for. So for example, let's say I wanted to solve for lowercase a. Well, in that case, we could use the version of the formula that looks like this. A squared equals b squared, and we used red for b. So b squared plus c squared minus 2b times c, and then we have cosine of a. So basically the way this works, and this is your angle, right? The way this works is whichever one you use within cosine, that goes on the opposite end of the equal sign, and the remaining two sides get utilized within the formula. So we can rewrite this instead to then have b squared equals, and then we use the remaining two sides. So it would be a squared plus c squared minus 2a times c, and then it would be cosine of b this time. So it all kind of depends on which angle you know or which angle you're solving for. If you have SSS, you really could use any of these. But it just really is completely up to you which version of this. And then the last way we could write it is if we want to use angle C, we could write it as c squared equals a squared plus b squared minus 2ab cosine of c. Remember, the capital letters stand for those angle measures. Okay, so let's go ahead and do an example where we solve this triangle utilizing our new law of cosines formula. Okay, so example 1 we have here. We're solving the triangle given the side lengths And it looks like in this case we have SSS. So we actually know all of the side lengths, but we don't know any of the angle measures. So really, it's up to you whichever angle you want to solve for first. I think I'm going to go ahead and solve for angle A first, which means I'm going to use the first version of the formula. Well, A is 5, so I'm going to plug that in as 5 squared equals B is 8 squared plus C, which is 12 squared, minus 2 times 8 times 12 times cosine of, and we don't know A, so just capital A for right now. Okay, so then I'm going to go ahead and clean this stuff up. So you're welcome to use a calculator if you'd like, but 5 squared, we get 25 equals 8 squared, which is 64, plus 12 squared is 144, minus, we have 2 times 8 times 12, so we get 192 cosine of A. And then we'll keep cleaning this up. We basically want to get cosine of A by itself, so that way we can go ahead and solve for that missing angle measure. Okay, so the next step, we're going to combine. We get 25 equals 208 minus 192 cosine of A. And then from here, we're going to go ahead and subtract 208 from both sides. So lots of algebra here. And then 25 minus 208, we get negative 183 equals negative 192 cosine of A. Okay, from here, we can go ahead and divide both sides by negative 192. And we can go ahead and, I guess I'm just going to reduce this for now, so we can leave it exact. So cosine of A equals, this reduces to 61 over 64. So then from here, what I'm going to do is just take the inverse. So A equals the inverse cosine of 61 over 64. Now, the nice thing is you actually do not have to worry about there being multiple answers to this, because remember, the angles on a triangle can only run from 0 degrees to 180 degrees, right? So they have to fall in quadrants 1 or 2. Well, cosine is actually only positive in quadrant 1, so there's only one solution to this, and we can use the inverse for that. So angle A is approximately, when you punch this in your calculator, I'm going to use degrees, so make sure you're in degree mode. A is approximately 17.612 degrees. Well, let's also use the same strategy to help us find angle B. Once we do that, we can find angle C just by using triangle angle sum theorem. So let's go ahead and use the second version of the formula. So we have B squared, 8 squared, equals A, which is 5 squared plus C squared, so 12 squared, minus 2 times 5 times 12 cosine of, and then this time we have B. We're going to go ahead and just algebraically go through this and simplify. So 8 squared, we get 64 equals 25 plus 144 minus, let's see, 2 times 5 is 10, times 12 is 120, cosine of B. All right, from here, we're going to go ahead and add. So we get 64 equals, we have 25 plus 144, so we get 169 minus 120 cosine of B. And then we're going to go ahead and subtract 169 from both sides. From here, we have 64 minus 169, which is negative 105, equals negative 120 cosine of B. Divide both sides by negative 120. I'm going to do the same thing where I'm going to leave it in exact form until I'm ready to put it in my calculator. So cosine of B, when I reduce negative 105 over negative 120, I get positive 7/8. And so B equals the inverse cosine of 7/8, which is approximately, let's see, if you punch that in a calculator, sorry, you get about 130, oh no, sorry, 28.955, sorry about that, degrees. Okay, well, once you get those two, you're ready to find your third angle, and you can just use triangle angle sum. So it just means that angle B plus angle A plus angle C equals 180 degrees. And so we can find angle C. I'm running out of room. Let me write it down here. C would just be 180 minus A minus B, which ends up being approximately 133.433 degrees. Okay, so there is one example of using law of cosines to help us in the case where we are given three sides. Okay, so let's do one more example, and then I'm going to have you guys work on the remaining. So this one, we end up with a side angle side case. So let's go ahead and first, we always want to sketch the triangle if there isn't a diagram already given. So I'm going to go ahead and draw out my triangle and label it A, B, C. So angle A is 46.5 degrees. Side B is 10.5, and then side C is 18. So we want to make sure that we label that appropriately. And from there, we have side angle side. Well, we do need to go ahead and solve for side A. So what I'm going to do is actually use the A squared version of our formula because we know angle A. So let's go ahead and start there. We end up with A squared equals, remember, you use the two remaining sides that were unused. So we have B squared, so 10.5 squared plus, this case, C squared. So we have 18 squared minus 2 times 10.5 times 18 times the cosine of 46.5 degrees. Okay, from there, we're going to go ahead and just clean all this up. I mean, really, this is a calculator problem from here. So we can clean this up. I mean, it's really up to you. You could punch this all in your calculator as is. I'm going to clean it up a little bit before I punch it in my calculator, but it's really completely up to you. You could just punch it in and square root it, right, to find A. Keep in mind, you only want the positive value, even though it would give you a plus or minus, because we're specifically talking about the side length on a triangle. So A squared equals 10.5 squared is 110.25 plus 18 squared, which is 324, minus 2 times 10.5 times 18 is 378, cosine of 46.5 degrees. I mean, really at this point, you don't have to clean it up much more. I would just punch it in your calculator and take the square root. So A, in this case, we only want the positive one, is approximately 13.193. So it's really just a lot of plug and chug. There's not a whole lot of math going on here. Okay, the next one we can solve for is an angle. We only really need to use law of cosines one more time, because once we get one of the angles, we can go ahead and solve for the other one using triangle angle sum. So A is about 13.193. I'm going to add that to my diagram. So now I'm looking and I only see I have two more things to solve for. So up to you what you want to go ahead and solve for first. I'm going to solve for angle B. So it means I'm going to use the B squared version of my formula. So B is 10.5 squared equals, now we have 18 squared plus 13.193 squared minus 2 times 18 times 13.193 times cosine of, in this case, we are using B because we use the B squared version. Okay, now we have to clean all this up. So 10.5 squared is 110.25, which equals 18 squared, which is 324, plus 13.193 squared, which you'll use your calculator. It's 174.05. I'm going to go 197. I'm going to go a couple decimal places beyond the 3 decimal place accuracy, just to make sure that my answer is as accurate as it can be. Okay, so minus, we have 2 times 18 times 13.193, which is minus 474.94353 is what I'm going to use, times cosine of b. All right, now we have to add to clean that up. We have 110.25 equals 324 plus 174.05197. So I'm going to add those up. I get 498.05197 minus 474.94353, lots of decimals, cosine b. Subtract 498.05197 from both sides, and we end up with negative 387.80197 equals our negative 474.94353 cosine of b. Divide both sides, and we end up with cosine of b is, and I'm going to use the approximation symbol because we 100% have to approximate that division. So negative 387.8 whatever divided by negative 474.94353, right? Punch that into a calculator. Or you could even, at this point, up to you, this is a lot of steps to write down. So actually what I usually do is I kind of skip steps a little bit, is when I get to this point, I typically just write that b is about the inverse cosine of all this stuff. It would be 387.80197 over 474.94353. And then when you punch that into a calculator, you get your angle, which is about 35.262 degrees, so about 35.262. Okay, and then from there you can just use triangle angle sum. So C would just be 180 degrees minus A minus B. Punch that into a calculator and you get that C is approximately 98.238 degrees. Okay, so that is it for today's lesson. I just showed how you can use law of cosines when you have 2 different cases, whether it's SSS or SAS. What I'd like you to go ahead and do is go ahead and complete numbers 3 and 4 on your own, and I will have the key posted to Google Classroom or my website so that you can check your work. Once you finish that, you can go ahead and start homework. All right, thanks guys. Have a good day.